In this lecture, we're going to learn about a bunch of algorithms that we can use to check and see if something applies to all of the elements in a collection, any of the elements in our collection, or none of the elements in our collection. Let's look at a simple example to really drive this home. So we have a bunch of collections here. We can use a vector, we can use a set, we can really use anything. We can even use a row array here. All of these are going to work because our iterators are going to be wrapped in std_begin. So this is going to allow us to even use row arrays. This is really cool. Now, if we go down, we can use the all of algorithm to check and see if a given property applies to all of the elements in our collection. And we do that by passing a beginning iterator and an ending iterator to our collection. That's what we do here. And after that, we're going to specify what we want to check for. And we will pass that as a callback. And in here, you see that we are using a lambda function, which is going to check and see if all of the elements in our collection are even. The lambda function here is checking to see if the parameter that we pass is even. And if it is even, the modulus operator is going to return 0 if we modulus by 2, as you see right here. So this is what we are testing for. If the check here is successful, we're going to know that all of the elements are even. If the test fails, we will know that all the elements in our collection are not even. So for example, even if we have one odd element, this is going to fail and we will fall in this block here. This is something you can achieve with the all of algorithm here. Now, some of you must be asking, isn't it possible to loop through my collection doing the check? Yes, it is possible to do that, but please take into account that it is possible that your collections might be completely different in how they are implemented, and you're going to have to set up different kinds of logic to loop around finding even numbers and then deciding if everything in your collection is an even number. But here we have a unified way to check and see if any collection only contains even numbers. You see, this is going to work for vectors, this is going to work for sets, this is going to work for row arrays. This is really a unified way, and this is the power of the STL, if you ask me. Now, we have other kinds of algorithms we can use in this family. For example, we have any of algorithm, and this is going to check and see if any of the elements in our collection satisfies a given condition. Here we will set up a custom functor, which is going to check and see if something is divisible by a given number that we pass as a parameter here. If it is divisible, we're going to return a true in our function call operator here, and we check for divisibility by using the modulus operator. You already know this. And once we have this functor, we can create an object of it and use it as a callback in our any of algorithm here. So we're going to pass a collection, we're going to pass the beginning and the end iterator, and then we're going to pass our callback and see if any of the elements in our collection is divisible by 7. If the test is successful, we will print the message here. If the test is a failure, we will fall in the second block here, and this is going to work as we want. Let's look at another example, and that's going to be none of. This is going to test and see if none of the elements satisfies a given condition. Here we have a simple function which is going to check and see if a given element is odd, and we will use this as a callback here. So we will pass a function pointer to that. We are going to use different kinds of collections here, and we're going to test and see if none of the elements is odd. If none of the elements is odd, we're going to put a message here, and if the test fails, we're going to fall down here. This is something you can do in your C++ programs, and this is really cool. Before we head over to Visual Studio Code and play with us, I want to bring it to your attention that you can browse for the documentation for all these methods that I am talking about. They have different overloads you can use. You can read this if you want. If you go down, you are even going to find a bunch of examples you can use to really try and understand this, if this is something I didn't have a chance to talk about in the course here. So now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is all of. We will grab our template files pretty quick and put them in place. And let's open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. Let's clean this up a little bit. And let's remove what we don't need right here. And we can close the sidebar here. And we're going to include the algorithms header. And how do I know I need to include this guy? If we go to the documentation, we're going to see that to be able to use these algorithms, we need to include this header here. So that's how I know this. We are going to hop over in our main function and set up our collections. And you see that we can set up our collection either as a vector, a set, or a row array. This is really going to work any way you set this up, because our algorithms from the STL are that robust. They can really work on a range of containers that you can throw on them. And this is really cool. The first thing we're going to look at is the all of algorithm, which is going to test and see if a given property holds true for all the elements in our collection. So this predicate here is going to test and see if everything in our container is an even number, because that's what we are testing for in the body here. And this is going to return true because currently everything in our collection, which is an array at this moment, is even. So we are going to print this message here saying that all numbers in our collection are even. Let's pass this through our compiler. We're going to use GCC for the task. The build is good, so we can bring up a terminal window and we can clear and run Rooster. If we do that, we're going to see that all numbers in our collection are even. Let's try and break this test here. We're going to put in a number that is not even. For example, let's change the 6 here to 11 and build again and see what happens. This is a good way to learn. The build is good, so we can clear and run Rooster. We're going to see that not all numbers in our collection are even. This is the situation we have here. Let's turn this back to be a 6 as we had before. And then we're going to show you that this is going to work regardless of any container we are using. So for example, if we use a set, which is fundamentally different from a row array, we're going to see that this is going to work. But for this, we need to include the set header. We're going to put this in, and we are going to also put in vector because we will need that in a minute. Now our program is going to be happy. We can pass this through the compiler. The build is good, so if we clear and run Rooster, we're going to see that all numbers in our collection are even if we are using an std set container. And you see that we didn't need to change anything in our code here because all these algorithms are going to work in a unified way for any STL container, and this is really cool. Let's comment this out and use a vector and prove to you that this is going to work. Also, we can pass this through our compiler. The build is going to be good, so we can clear and run Rooster, and we're going to see that this is going to work. If we try and change 70 here to 71, for example, to put in one odd number, we're going to see that this is going to fail and tell us that not all numbers in our collection are even. And this is something you can do in your C++ programs. Let's try and build. The build is good, so let's clear and run Rooster. We will see that not all numbers are even, and this is something you can use in your C++ programs again. Now, as you learn about these algorithms, I would challenge you to keep a piece of information in the back of your mind that anytime you want to do something, it is a good idea to come back to the algorithms library here and see if you can't find a ready-to-use algorithm and use that in your C++ program. Many people, including even some pretty experienced C++ developers, will try to go down and really build everything themselves, but it is a good idea to try and reuse these algorithms because they are data tested, they have been in use for many years, and they are going to make your life easy if you develop a habit of using them in your C++ program. So make sure you nurture this habit as you build more programs using C++. Okay, now that you know this, we're going to put a separator and learn about another algorithm within this family. Let's go down and try this out. This is going to be testing to see if any of the elements satisfies a given property. Here we are going to set up a simple functor which is going to check if something is divisible by a given number. and we're going to be using our function called operator here, which is going to decide whether a given number is divisible by our number here, and the number is going to be passed as a parameter to our functor here. This is how we're going to do this. Now, once we have this functor, we can use it with our any of algorithm. We're going to pass in the beginning iterator, we're going to pass in the end iterator, and then we're going to specify that we want to test and see if any of the elements in our collection is divisible by 7. If the test is good, we're going to know that at least one number in our collection is divisible by 7. And if the test fails, we're going to know that none of the numbers is divisible by 7. It is this simple here. We're going to be working on the same collections we have seen on top here. So one quick number that is divisible by 7 is the 70 here. So the test is going to fall down here, and we're going to say that at least one number is divisible by 7. Let's pass this through the compiler. We're going to use GCC again. The build is going to be good, so we can clear and run Rooster. We're going to say that at least one number is divisible by 7. Let's change this to 71 and see what we get. We can pass this through our compiler. The build is good, so let's clear and run Rooster. We will see that none of the numbers in our collection is divisible by 7. But if, for example, we change the 40 here to be 49, I think this is going to be divisible by 7. Let's try this out. The build is good, we can clear and run Rooster, and we're going to see that at least one number is divisible by 7 because 49 here is divisible by 7. This is something you can do in your C++ program. Again, this is going to work on a range of STL containers. For example, we can use std vector, and the code here is going to work unchanged. This is really cool. Let's pass this through our compiler. We're going to see that at least one element is divisible by 7 because we have an asymmetry in our vector here. This is what we have. We can even use this on a row array. This is going to work really well. So let's build this program here. And we're going to see that the build is good. We can clear and run Rooster. And we're going to see that at least one number is divisible by 7. That's going to be our 70 that we have in our array here. There is another algorithm in this family, and that's going to be any of. Let's go in here. We're going to see that we want to look at none of here. We have looked at any of. So let's try this out in Visual Studio Code. And this time we want to use a regular function as a callback, and we will pass this as a function pointer. So let's go down and do that. We're going to put in our code to call our algorithm. It is going to check and see if none of the elements satisfies a given condition or a given property. And here we want to test and see if something is odd in our C++ program or in our collection. So if none of the elements is odd, we're going to fall in here. So the condition is going to succeed here. If the condition fails, we're going to fall here and say that at least one number is odd in our C++ program. Let's go in and see what we have. We have this array. None of the elements is odd, so we are going to fall here and say that none of the numbers is odd in our collection. We can pass this through the compiler to prove this. The build is good, so let's clear and run Rooster. We're going to see that none of the numbers is odd. This is going to work on a range of STL containers, so we can use std set. We can pass this through the compiler. The build is good, so let's clear and run Rooster. We're going to see that none of the numbers is odd, and if we go in, we're going to see that none is odd really. We can even use our vector, but this time we have in one odd number, which is this 71 here. So what is going to happen? We're going to print at least one number is odd in our collection. Because of this 71 we have in the collection right here. Let's pass this through the compiler. We're going to use GCC. The build is good, so we can clear and run Rooster, and we're going to see that at least one number is odd. This is really all I wanted you to see. These are pretty cool algorithms if you want to test for a given property across all elements in your collection. And this algorithm was used in iterator pair mod because we had to pass the beginning iterator and the end iterator to try to use it. And hopefully this is going to drive home a pain point many C++ developers had, in that you really want to test for a given property on your collection, but you have to pass the beginning iterator and the end iterator, even if you really want this to be tested on the entire container. So it really makes sense to be able to pass the entire container immediately without explicitly specifying the beginning iterator and the end iterator. And we're going to solve this problem in the next chapter when we use range algorithms. But we're going to learn about iterator pair algorithms first in this chapter here to give you a good start on these things. As usual, if you need more information on these things, please use your favorite reference for the C++ standard library. You can come here, for example, at CPP reference, and you're going to see even more overloads for these methods. You can use them if you want. You can see all the information about these methods here, and you are even probably going to see more things than I had a chance to talk about in this lecture here. We are going to stop here in this one. In the next lecture, we're going to learn about the for each algorithm. Go ahead and finish up here and meet me there.